Hi everyone, welcome to the 7th video in the Quantitative Methods course. In this video we'll be talking about moderation in linear models, specifically OLS models. And as we will have discussed in class, moderation means that the effect of one variable depends on the value of another variable, the moderator. And the way you go about it in Stata is of course to first load up data, as we'll do here, the CompuStat data that we've been working with. And in the next few minutes we'll be checking whether the effect of cash on gross profits depends on the new moderator, the amount of money spent on acquisitions. That's AQC in the CompuStat data. Before we turn to the regression model, I'll first need to discuss a little bit what they call factor notation of Stata. In order to test moderation in any sort of statistical model, you would need to interact two variables with each other, the independent variable and the moderator. You can do this by first generating a new variable, which would be cash times acquisition in this case, and then putting that into the model. However, as we'll see soon, that actually doesn't work in Stata. What you instead need to use is this factor notation. We've seen a little bit of it already. Specifically, we've seen this I dot before, and you might recall that this you need to use I dot for categorical variables, being either dummy variables that can be 0, 1, or a variable with multiple groups, which we have done for year. So if we run I dot year, you will have seen in the regressions separate dummy variables for every year value in the data, taking one of the years as the so-called baseline category. And something new here is this C dot. You use that to indicate that the variable is continuous. So that goes from basically any possible value rather than categories. You will also see here now these double hashtags, and that's what I would always recommend to use if you want to make interactions in your models. What this double hashtag does is generate not only the interaction cash times acquisition, but it will also include all the lower order terms. So what that means here is it would not just have the interaction, but it will also have cash and acquisition separately. And let's see here what happens when we do C dot year. Now what you see here is, like I mentioned, cash separately, acquisition separately, and cash times acquisition. So this is what they call the interaction term. And also because we did C dot year, it sees year as a continuous variable, so it will just take a single variable into the model, and we'll take that as continuous. If we now run this second line with I dot year, what you see and what we have seen before is that Stata will generate for every year a unique dummy variable, taking 2010 as the baseline category. Now you can also interact continuous variables with categorical variables. The easiest would be just to do a dummy, but we can also do with generally categorical variables like year here. And what Stata then would do is generate the interaction between year and cash for all these different years. So this means 2011 times cash, 2012 times cash, etc. It would take all the lower order terms again, so here all the year variables except 2010, and it would have the cash variable. Of course, this gets very messy quite quickly because it means there's 6 interaction effects. So generally, I would not advise you to do something like this, but this works very well, for example, with a dummy variable. You can also interact more than 2 variables. So this is what they would call a 3-way interaction. And what you see here is the 3-way interaction. So that's cash times year times acquisition, year times acquisition, cash times acquisition, the lowest order term of acquisition separately, cash times year, and cash. So this is really the key benefit of using these double hashtags, because it will include all the required terms. If you just include single hashtags, it will only include, for example, this one if you use single hashtags here, and then you would miss out all these lower order terms and your model would be wrong. That said, let's turn to the actual model that we'll be working with. Let's regress gross profits on cash times this acquisition spent. These are both continuous variables, and we'll use this double hashtag. And let's control for year dummies. And again, we always use robust standard errors. This is the model that we have seen already. And as we have discussed in class, what this lowest order term means for cash is that this is the effect of cash when acquisitions is exactly equal to 0. We see that this is positive and significant. The coefficient for acquisitions is the effect of acquisitions when cash is 0, highly significant. And we also see a positive interaction term, again highly significant. And this is a necessary condition for there to be any sort of moderation. Had this not been significant, we could have just stopped and said, there is no moderation, full stop, we're done. Just to illustrate a little bit more this factor notation, what I just ran would be equivalent to running this line here, regress GP, cache acquisition, and then the interaction just using this single hashtag. So this just means only the interaction, not the lower order terms. So if I remove these two, it will only generate this interaction, and that's wrong. As we will have discussed, you need to go beyond just looking at the interaction term. You need to also substantively interpret the moderating effect. You would do this by plotting the effect of cache at specific values of acquisitions. And you need to do this for meaningful values. So let's just check how the variables look. We have seen cache already, so I won't belabor that too much. But we can see now for this new variable acquisitions, how it's distributed. The lowest value is minus 20,000 or so. The fifth percentile is 0, so I would in general recommend using the fifth percentile. This means that less than 5 or more than 5% of the firms in our data actually don't have any spend on acquisitions. Even more so, the median, the 50th percentile, is also 0. So this means that the majority of firms in our data actually don't spend anything on acquisitions. And we'll also use the 95th percentile, which is 249. So given that the median and the 5th percentile are the same, we'll actually just calculate those lines that we have seen in class for the 0 value being low acquisition spend and 249 being high acquisition spend. And we'll use the margins command that we've seen a few times already in class and in the videos for this. So we're going to first just plot the line, so the predicted value of gross profits across the range of cash. So that goes from minus 0.04 up to 423,000. Let's do that in groups or increments of 10,000. And then for those two values of acquisitions that I've mentioned. So this might take a little bit because it's going to calculate a lot of specific values. So specifically, for example, cash being minus 0.04, at acquisition is 0, cash is minus 0.04, at acquisitions is 249, etc., etc. So that's what all these values mean, as you can also see up here. Thankfully, we don't need to do much with these specific values. Stata can just plot all these graphs or all these values in a graph. We're going to use the margins plot command for this with the option no CI. And doing so, you get two lines. You get the line for cash when the acquisition value is low, and you get the value for cash when acquisition is high. I just realized that I just still had stored this last model that we ran without the lower order terms. Recall that one was wrong. So let's actually restore the original regression model that we've had, like this. And now if we run this again, we'll actually get the correct results. So again, it's always very important to be mindful of which model you just ran, because as you can see here, the prior model had a very, very different effect than what we had here. In the wrong model, we saw basically no effect of acquisition or of cash when acquisition was low, and a very strong positive effect when acquisition was high. That would have been wrong. This is the correct line, or these are the correct lines. As you can see here, very barely you can see the blue line that represents the effect of cash when acquisition is low. The red line represents the effect of cash when acquisition is high. You see that the lines are slightly different. The one for low acquisition spend is slightly less positive than the one for high acquisition spend, and we know that this difference is actually statistically significant, but in practical terms it's very clear that these differences are just not meaningful. Another way to look at it would be to calculate the marginal effects of cash, so that would be the slopes of those two lines that we just saw. Let's again restore the model, and then we use the margins command with dy dx cash at these different values of acquisitions. I'm now adding 1 just to show you something soon, but this 0 was the 5th percentile and this was the 95th percentile. So restoring the model and running that, you now see that this is the effect of cash. So if cash goes up by 1, gross profit goes up by this much when acquisitions is low. When it is 0 specifically, when acquisitions is high, this is the effect of cash. So if cash goes up by 1 and acquisitions is 249, this is the effect of cache, and indeed you see it's slightly larger, but barely meaningful. But why I did this, including this one, I just want to illustrate one thing. So let's see how Stata stored our marginal effects just now, and let's compare the effect of cache when acquisition is 1 with the effect of cache when acquisition is 0. And here you might see this 0.401133. And if we just run the model again, that's also exactly what this interaction term is. So what I just want to show you here is the interaction term is essentially the change in the marginal effect, so the change in the effect of cache as acquisition goes up by 1. Right? You can see that here, it's exactly the same. Now to conclude what we have done now, we have seen that there was a significant positive interaction term, so this suggests that the effect of cache was positively moderated by acquisitions. However, when we both plotted the effect of cache across its range, as well as just checking the marginal effects, it was very clear that actually in economic terms, this effect was not meaningful. So this just highlights how important it is to really substantively interpret your moderation effects. Finally, just going into some more specifics about how to approach moderation to start. I mentioned at the start you can generate also separately this interaction variable. We can use the generate command for this. So we can generate a new variable, let's call it interaction, being cache times acquisition. Now you will see in the bottom of our data set here, there's this new variable interaction. And we can also regress then GP, gross profits, on these 3 variables. These are exactly the same results as we had. Well, if we can include year, that is. So now it's exactly the same results as we had. You see this one, we just saw that as well. Let's store that as wrong model. But if we then run or compare, for example, the slopes, you see that actually Stata doesn't know that this interaction term that we put in the model is made up of cache and acquisition. You can see this by the fact that when we fill in different values for the acquisition variable, Stata thinks that the slope of this cache variable is actually just the same, because it does not know that this interaction term is in the data. And if you take the derivative of this and taking this as a separate variable rather than as an interaction term, you will indeed see that only the coefficient for cache, which is this one, would be the marginal effect. So just to emphasize here, what I meant to say and what I want to illustrate here is you should never first generate a separate variable and then put that in the model, because your coefficients wouldn't be wrong, this is still correct, but Stata would not be able to help you in really interpreting these effects. That's all I wanted to say for the moderation part. Hopefully it's clear. Take some time to look at it. If there's any questions, feel free to let me know. But this is really all that you need to use for any sort of moderation. We'll see when we move to nonlinear models. The setup will actually be pretty much the same as what we do now, except that then the interaction term will have a different meaning. Thanks for watching, and in the next video we'll be talking about mediation.